Hello everyone, this is G4 and our team member involves Feng Wai, An Yu Taibing and Li Yuxuan. Today we will talk about Trusted, which is a Python's asynchronous networking framework. However, before we go into Trusted, let's talk about threading models first. In single-threaded synchronized, the new task can be only executed after the completion of the previous task, even if the thread is idle. In multi-threaded synchronized, each task is executed independently, and in asynchronous, the second task can be started without the completion of the previous tasks. For example, you need to deliver coffee from 3 auto coffee machines. In single thread, you wait for the machine 1 first, even if machine 2 completed early. In multi-threading, you have 3 staff taking in charge of each machine. And in asynchronous, if machine 2 complete earlier, you will deliver coffee from machine 2 first instead of machine 1. Let's go back to the story of Twisted. In 2000, a guy named Gleefer was developing a game in Java multi-thread model. However, the thread crashed with each other and it's very difficult to score. So Gleef turned to Python to select model for multiplexing I/O from streaming objects, proves less complex and more reliable. Gleef using Python Medusa platform first, however, Medusa still requires developer to manipulate scorecard directly. Its Windows support was buggy as well, so he decided to develop event-driven Twisted framework which can make a network call without blocking the application.
Before we start with Twisted, let's start with some basic concept. The scenario is when a client downloads the poem from 3 servers and each serving 3 different poems. The client will wait until one poem finished and moving on to the next one. The expected output will be something similar like this, and the total time is around 23 seconds. And obviously, the downloading is a block operation. In the same context, the asynchronous client downloads some byte from each server and bring out the line each time they receive data. They have a longer output compared to the previous one. In case there's any slower server, it will automatically adjust to the speed of a slower server while keeping up with the faster one. The asynchronous client finishes around 10 seconds, while the previous one is at 23 seconds. It's because of the asynchronous client spend less time blocking. Within the asynchronous client context, each connection is an open socket. It waits on all socket until one or more socket has data. For each socket, only can read as much data as available. And the whole process repeated until all socket has been closed. And this type of a loop, which exactly is a reactor loop, is a core circuit in Twisted. Reactor know the network, file system, and event. And this is a simple hello Twisted program. By looking at output, note that the hello function is called after the reactor starts running. We arranged for this to happen by invoking the reactor method call when running with a reference to the function we want Twisted to call. And look at the reactor loop itself. Actually, the callback code runs in the same thread as the Twisted loop, and actually it's single-threaded. And this is a full implementation where the client will get a poem from a server with a stack of callbacks. And reactor.stop is reside within the got_poem method to stop the reactor within the got_poem. If a server is non-existent, actually the reactor just runs forever. However, in Twisted, it's possible to implement an arrow callback or in short, arrowbacks. So we have a stack of callback and stack of arrowbacks.
Differs in Twisted are somewhat similar to features in Java. Differ represents an asynchronous result, or a result that has yet to come. By returning a defer, the API is saying that whatever is asked for might not be done yet. As such, the callback chain of this defer will return with the result. On the other hand, if something goes wrong, the back chain will be called to handle the error. Calling a defer allows you to process the result when it is ready. However, defer does not change the mechanics of an asynchronous model. In particular, a callback that blocks will still block if attached to a defer, and hence the program itself will block. As such, defers are only a solution to the problem of managing callbacks, not the way to turn blocking callbacks into non-blocking callbacks. In some cases, we want our program to execute differently depending on what kind of error occurs. Further, since a bug can exist anywhere within the code, we want to be able to wrap every callback in an extra layer of try-catch statements, such that the exception arising from the callback can be handled well. The same goes for callbacks because code to handle errors can have bugs too. A defer solves such issues. It contains a chain of ordered callback or back pairs or stages. In a given stage, if all goes well, the next stage callback is called. If an error occurs, the callback is called to handle the exception, and the control moves back to the callback chain. This continues until the last stage, where the result is returned from the deferred. So now we have a background of Twisted functionalities. Here's a big picture overview of Twisted programs. The clients interact with the reactor node, which is monitoring the client sockets. The transport represents a connection that the client sends or receives bytes. The protocol is a specific networking protocol such as TCP that the connection uses. and the protocol factory makes protocol instances.
So this is a simple implementation of a twisted TCP server. Starting from the bottom, you can see the reactor is listening to port 8000 using listen TCP. There's an echo factory that is creating instances of the echo protocol, which is defined above. In the next, we will see a TCP implementation versus a UDP implementation. As you can see, the only difference here is that the difference is at the protocol and the transport layer models. You can see that Twisted actually does a lot of abstraction for the users, such that there's no socket layer abstraction and there's a lot of reusing of inherited classes, transport classes. So this is a story of NetString receiver. NetString receiver is a protocol that appends the amount of data it has in front of the actual message. The law has it that the creator of NetString receiver wanted to receive TCP message and return NetString receivers. And his implementation was so good, it was eventually merged into Twisted library. So people are comfortable with Python because it is fast. Twisted is fast, it uses concurrency and asynchronous. There's extensive library of low-level protocols which allows for extraction, reusability, and simplicity. The framework is also powerful, such as you can do load balancing and also SSL and TLS. So companies that are using Twisted are NASA, Lucasfilm, TweetDeck, FluidDB, Ubuntu, and a search on GitHub shows over 1,500 code samples. People usually use Twisted for libraries and add-ons, applications, games, and research projects.